Hi, I'm Tom Anderson, and I'm going to walk you through an introduction to the cloud and the Amazon Web Services Cloud Infrastructure Platform. Early in internet development, you could actually create a diagram of all the different nodes and interconnections. But after not too long, the internet grew much too fast and there were too many nodes and connections to reasonably illustrate. The network diagram of the internet was replaced by a cloud metaphor representation, indicating that there were many nodes and interconnections within, but that particular details were unimportant. The internet was sort of a black box where the only important features were the inputs and outputs, which were prescribed by standards. And this is where we get the name cloud. While there are many examples of predecessor technologies on which the current conception of cloud computing was based, our modern understanding of cloud computing started in August of 2006 when Amazon created a subsidiary called Amazon Web Services and introduced its Elastic Compute Cloud, or EC2, which is essentially a reboot of the mainframe time-sharing model from the 1950s. However, what has changed between then and now is virtualization. The cloud is at its heart servers and network switches and data centers over which resources can be provisioned virtually through software. What this means is that end users can create software-defined virtual private networks which simulate internet nodes and connections within what amounts to a giant supercomputer. The AWS cloud is composed of dozens of data centers spread around the world, each of which contains tens of thousands of servers. But the physical architecture of the cloud infrastructure isn't very important to the end user because virtualization allows them to simulate whatever kind of infrastructure they need. And it can change it almost instantaneously in response to changing requirements or demands without having to worry about the underlying hardware. There are multiple models or levels of cloud virtualization, wherein the user is responsible for varying levels of configuration and maintenance. The most basic level, which is most like managing a traditional data center, is Infrastructure as a Service, or IaaS. The customer is responsible for the security, maintenance, and availability of the resources they provision from the cloud, including backups, scaling, user access, etc. For example, EC2 instances, which are virtual servers, or EMR clusters, which are big data processing engines. AWS is responsible for the security, maintenance, and availability of the cloud itself, including the core services underlying the virtualization. The next level is Platform as a Service, or PaaS. In this case, the customer is responsible for the security and maintenance of their data, both in storage and in transit, as well as the configuration of some service management details, while AWS handles the security, maintenance, and availability of the servers, operating systems, and system software on top of their management of the core services and infrastructure. Examples of this include Amazon RDS, which is a relational database management system, or Elastic Load Balancers, which simulate physical network routers. The most abstracted level is Software as a Service, or SaaS. Here, the customer is minimally responsible for the security and maintenance of their data, and AWS handles the security, maintenance, and availability of the software application, as well as the servers, operating systems, and system software on top of their management of the core services and infrastructure. Examples of this include Simple Storage Service, or S3, which is like a virtual network drive for file storage, or Lambda, which is a virtual runtime environment that will run code independently of an explicit operating system. One of the most important advantages of using a cloud platform such as AWS is that they take care of the basic infrastructure security, certification, regulatory compliance, and framework compliance, which would otherwise require significant time investment and expense from an enterprise rolling their own solutions. Other advantages revolve around the fact that Amazon assumes some responsibility over hardware and software, leading to less internal administration. But probably the biggest benefit is the enhanced scalability. When you run your own data center, you have to size hardware to meet the reasonable demands of end users, even during particularly heavy usage times. If the hardware is undersized, then your services suffer from slow responses and possibly even denial of service. But because cloud services are virtual, you can allocate a much smaller average footprint for low demand times and then instantaneously scale up resources to meet large transient demands. And you only pay for what you use, not a data center that's sitting idle or underutilized much of the time. This also gives you improved performance, even under heavy load, and fewer potential bottlenecks or failure points. As such, you suffer virtually no downtime, and if you do encounter loss of service or data, it's much easier and quicker to recover. The main disadvantages to using a cloud platform are some loss of control over the configuration and potentially adding some costs if the implementation is not well engineered. This would mostly happen if you don't utilize cloud optimizations such as elastic scaling and instead just leave oversized server instances running even though there's no end user demand for it. Enterprises almost universally find that utilizing the cloud significantly reduces costs. The AWS business model is predicated on economies of scale that make AWS costs lower than the fees they charge, even if the fees charged are lower than customers would otherwise pay on their own solutions. The pricing model includes a pay-as-you-go or on-demand, reserved instances, volume discounts, and spot pricing. This allows Amazon to both provide the best possible prices for the customers and also use the most capacity and maximize the usage of their infrastructure. Various big-name software companies have been playing catch-up to Amazon, trying to leverage their customer base, but have fallen short so far. The primary competitors to Amazon include Microsoft, Google, Alibaba, Oracle, and IBM. In conclusion, Amazon Web Services remains the premier cloud platform, serving customers which include Netflix, Facebook, LinkedIn, Twitter, BBC, Baidu, ESPN, and Adobe, among many others. Enterprises both large and small experience a plethora of benefits with very few disadvantages by moving their physical data center or even just particular applications to a cloud platform.